Hello fourth year, welcome to a really quick recap on redox equations. I was looking through some of the metals practice questions that have been handed in and I realised that some of us are just a little bit unsure of the redox equations or need some polishing on the area, so I thought I'd run through it again. So redox reactions, what are they again? Reactions in which both oxidation and reduction take place can be called redox reactions. Wait a minute, oxidation, reduction, just remember oil rig. So oxidation is the loss of electrons and reduction is the gain of electrons. So on page 10 of the data booklet we have the electrochemical series, which is a list of reduction reactions. As we can see here, reduction reactions have their electrons on the left hand side of the arrow. If we wanted to write an oxidation reaction for any of the elements on this series, you would simply flip the equation around. So what do I mean by that? Okay, so let's start with lithium then. So the reduction reaction for lithium ions forming lithium atoms looks like this. The reverse reaction, lithium ions becoming lithium ions, would be an oxidation reaction. So all of these reactions here are reductions. If we wanted to write the oxidation reaction, we simply change the direction of the arrow and flip the equation around. So let's go back to redox. Remember, redox are reactions in which we have reduction and oxidation taking place at the same time. What we need to be able to do is take a reduction reaction. What we need to be able to do is take a reduction equation and an oxidation equation and combine them into one single redox equation. It's all about practice, practice, practice. So we are going to start by combining this ion-electron equation to form a redox equation. So what we have here are copper ions being reduced to copper atoms. At the same time, magnesium atoms are being oxidized to magnesium ions. Now, let's just remember, redox equations have no electrons. So when we are combining these equations together, we need to get rid of the electrons. Now this example is quite straightforward. We have 2 electrons on the left hand side of the equation and 2 electrons on the right hand side of the equation. So we simply cross them out. They are eliminated. We can then combine what is left of our reduction equation with what is left of our oxidation equation to get our full redox reaction. Like so. Here we have another example. This time we have silver ions being reduced to form silver atoms, and again magnesium atoms being oxidized to magnesium ions. Now on this occasion we have 1 electron on the left hand side and 2 on the right, so they won't fully cancel out. what we have to do here is take this whole equation and multiply by 2, which gives us 2Ag plus 2 electrons produces 2AgS. We then combine this equation with our oxidation equation because we can now cancel out the electrons. So it becomes 2Ag plus Mg S gives 2Ag plus Mg 2 plus. And there we have another redox equation. Our final one, slightly trickier from the looks of things, but we do the exact same thing again. We want to cancel out our electrons on both our reduction and our oxidation equations. So in my reduction reaction, I have 5 electrons. They are on the left-hand side of the arrow. And in my oxidation equation, I have 1 electron on the right-hand side of the arrow. So I'm going to take this entire equation and multiply by 5. This will give me 5Fe2 plus giving 5Fe3 plus and 5 electrons. I can then cancel out the electrons on the left-hand side and the right-hand side of our equations, and we then combine the two together. So it's MnO4 minus plus 8 hydrogen ions plus our 5 iron ions. And that gives, I'm going to move it down here because I don't have enough space, the manganese 2 plus ion plus water plus 5 iron 3 plus ions. So that's one of the things that questions will ask you to do with redox reactions. They'll ask you to produce a redox equation. Another thing you might be asked to do is to identify the oxidation and reduction reactions from the redox equations themselves. So in the reaction here, we have calcium plus magnesium sulfate given magnesium and calcium sulfate. The very first thing that I would recommend you do is you break this down into an ionic equation. So the calcium we have here is just calcium metal, so it's just solid calcium. We have a solution of magnesium sulfate, which means I have Mg2 plus ions alongside SO4 2 minus ions. On the other side of my equation, I just have magnesium metal, and I now have calcium 2 plus ions and, as before, our sulfate 2 minus ions. Just from looking at this ionic equation, I can safely say that the sulfate ion is not involved in any part of the reaction. It can be completely cancelled out. It's a spectator ion. So that is neither oxidised nor reduced. So what is happening here is that calcium is becoming calcium 2+ ions. This would be our oxidation, since in order to form an ion, calcium must lose electrons. Magnesium, on the other hand, begins the reaction as magnesium ions. It then gains electrons to form magnesium atoms. In this instance, our calcium is being oxidised and our magnesium ions are being reduced. Okay, so let's look at another example. Here we have copper nitrate with zinc becoming copper and zinc nitrate. So like in the first example, I'm going to break it down into an ionic equation. So we have copper 2+ ions. We have 2 nitrate ions. We have some zinc. And these give us copper plus zinc ions plus our nitrate ions again. Now, like in the last example, there are spectator ions present. The spectator ion this time is our NO3, so that's not taking part in the oxidation or the reduction, it's just there. Now, our copper 2+ ions are becoming copper atoms. To do this, they have to gain 2 electrons. So this would be our reduction reaction. Our zinc atoms are becoming zinc ions, and this requires the loss of 2 electrons. So this would be our oxidation reaction. Our last reaction is a slightly trickier reaction. What I'm going to do is I'm going to break this down into just the iodine and just the iron aspects of this. So we have 2 iodide ions, and they are becoming a molecule of iodine. Now, to do that, this negative charge means that both of these have gained 2 electrons. What they have to do to form their I2 molecule is lose those electrons. So in this example, iodine or iodide ions rather are being oxidized. In the case of our iron 3 ions, they are becoming iron 2 ions. Now, in order to go from iron 3, so this is an iron atom that has lost 3 electrons, to an iron ion with only 2 electrons lost, we must gain an electron. So this would be our reduction reaction. Now I know that was pretty quick, but that summarises very quickly some of the different questions you might be asked based on redox equations. Now, I hope it's been of use to you. If not, please let me know. It's really important that you let me know if you are still struggling, because these questions come up time and again in assessment. So get in touch if you need any more help. Remember, I am always available whether you are timetabled in chemistry or not. Just send me an email and I'll get back to you as soon as I can. Thanks for tuning in, guys, and I will speak to you all soon.